All right, on this lesson 5, we're going to be talking about the normal distribution. All right, first things first, empirical. The empirical rule. It says 68% of the data lie within one standard deviation of the mean. 95% of data lie within 2 standard deviations of the mean, and 99.7% within 3. This is a golden rule of thumb. So for example, if I have a normal distribution where these are, let's say, shoe sizes for men, and let's say the mean is, whatever, 6, and the standard deviation is 2. So here's 6. Now, 2's a little too much. Let's say 0.5. So the average shoe size is 6, and then it's give or take 0.5. So 6.5, 7, 7.5, 1, 2, 3, 5.5, 5, 4.5. So this is within 1 standard deviation, give or take. 68% of all men will have shoe sizes between 5.5 and 6.5. Within 2 standard deviations is this. So 95% of the data, or 95% of all men, will be between 5 and 7, and from here to here, that's 99.7% of all men will have shoe sizes within 3 standard deviations, or 4.5 to 7.5. So if I were to say find the probability that a randomly selected man has a shoe size, let's say greater than or equal to 6, well, that would be 50%, because that's halfway between the data. Oh, by the way, these mean the same thing in regards to a normal distribution. And we're going to let X be a randomly selected man. Thus, that's why we can say that. So if I said find the probability, X is between 5.5 and 6.5, that'd be 68%, 0.68. So I could say other things like find the probability, X is less than 5.5. Well, so I'm looking for this part. Well, I know from here to here is 68%. The whole curve has to be 100. So what I'm going to do is I'm going to do 1 minus 0.68. So that means on the outside I have 32%. See? So cut that in half, divide that in 2, 16. So that's 0.16. If I said find the probability, X is between 5 and 6.5. So now I want from here to here. Well, I know that's 68. What's that little part? Well, from here to here is 95. So if I do 1 minus, okay. All right, from here to here is 95. So to find that one, all right, let's see, that's 95. So I could do 95 minus 68. 0.95 minus 0.68, 27. So that means here and here have to add up to 27. Cut that in half, 0.135. Right? Because if from here to here is 68 and here to here is 95, if I subtract them, I get the excess right in here. And that excess was 27%, so cut it in half, I get this part. And what if I said the probability x is greater than 7? Well, from here to here is 95. So if I do 1 minus that, I get 0.05, and now I want this side only, so cut that in half, 0.025. So that's how you can find, you know, some of these partitions using the empirical rule. By the way, I'm not going to use the sheet because it's just too confusing for me. There's just too much in there, so I'm just going to dumb it down on paper for today. All right. So that was men's shoe sizes. So let's say men have all right, so men had an average shoe size of 6 and it had a standard deviation of 0.5. Let's say women have an average shoe size of 5 with a standard deviation of 1.2. And Abby has a shoe size of 6.3. And let's see, Uzi. Oh, I hope I spelled that right. I know I didn't. Sorry, Uzi. Has a shoe size of 7. Actually, wait. Let me think about this. All right. Uzi's going to have 6.8. So who has a bigger shoe size? Bigger foot. Well, clearly Uzi. But if I said, who has a bigger foot relative to their gender? So, like, does Abby have a bigger foot for a girl than Uzi has for a guy? So the problem is that I'm trying to compare apples to oranges, and I can't do that. So what I have to do is I have to standardize these values, and this is where we get the standard normal curve or standard normal distribution, and these use z-scores. A z-score is also called a standard score, and it tells us the number of standard deviations away from 0 in either direction, left or right. So the formula is you take your data point, minus it from the mean, divide it by the standard deviation. So watch this. Okay, so Abby has an x of 6.3, but her z-score is 6.3 minus her mean, the woman's mean, divided by a woman's standard deviation. Uzi's shoe size is 6.8, so Uzi's z-score is 6.8 minus the male mean divided by the male standard deviation, 1.6. So Abby is 1.1 standard deviations above the mean. Uzi is 1.6 standard deviations above the mean. Uzi's foot is bigger. Oh no, for a male then. No, they are having a great time up there. Bigger than a female. Okay. So the standard normal curve, separate. See, here's all the z-scores. Z equals 0 means you're right at the mean. So 1, 2, 3. So it's just going out by z-scores. So now I can compare apples to oranges. So if I want to say, oh, who's taller, LeBron James as a man or some woman from the WNBA as a woman? So then you can compare apples to oranges by converting them to z-scores and then comparing their z-score, the number of standard deviations away. Okay, so example, let's stick with, let's do men's heights. Men's heights are going to be normally distributed with a mean of, I have no idea, 5.8, standard deviation of 0.6. If I want to find the probability equals some randomly selected man, if I want to find the probability that some man is greater than 6.32, the empirical rule is not going to work. You only use the empirical rule when the book tells you to use the empirical rule. But if it's written like this, what I'm going to do is, all right, 5.8 is in the middle, 6.32 is right here. So I need to find the area under that curve. And the way to do that is to use normal CDF, and then the lower bound is 6.32. The upper bound is 99999. Basically, you want this to be a huge number, so just put a bunch of nines. The mean is 5.8, standard deviation is 0.6. So you can find this under second VARs. So what a normal CDF, not PDF, CDF. Okay, so if you have the old operating system, then you do this, but going horizontally, not vertically. So 6.32, comma, put the comma in there, and put a bunch of nines, comma, 5.8, comma, 0.6, enter. So it's about 19.3%. Okay, so once again, I went to second VARs, norm CDF. If you have the new operating system, you're going to go second VARs, and then it's this way. So 6.32, 999, 5.8, 0.6. Okay, so what does this mean? So about 19.3% of men are taller than 6.32. So 1 minus 0.193 is this. So this would be 0.807, Because remember, this whole thing has to add to 100% or 1. If I know 0.193 is in this blue shade, 1 minus that gives me 0.807. So that man is at the 81st percentile. So a percentile, well here. Okay, if he's at the 81st percentile, then he is taller than 81% of the men. Let's do another one. Okay, let's say I wanted the probability x is less than 5. So I'm going to draw a curve. Here's 5.8. Here's 5. Now I want this one. So normal CDF. My lower bound, now it has to go left to right. My lower bound is in 5. My lower bound is right here. It's lower from the shade. This is a really small number. -9999. My upper bound, right here, it's 5. Mean 5.8, standard deviation 0.6. .09. Let's just say, whatever, 0.09. So that man is at the 9th percentile. He's not that tall. He's only taller than 9% of the other men. But, alternatively, he has a lower center of gravity. So, whichever one you find to be most beneficial. So if I said the probability 5.5, this one, so now I want a range. I want between 5.5 and 6.9. So that's going to be normal CDF. Now my lower bound is here. 6.9 is here. 5.8, 0.6. .66. So the probability a man is between here and here is about 66%. So if I reached into a bag of all men, pulled out one of them, there's a 66% chance he's between this and this with heights. All right, next question. What if I wanted the probability a z-score is greater than 1.6? Well, here's 0. Here's all my z-scores. Here's 1.6. Well, z-scores have a mean of 0, a standard deviation of 1, always. So I'm going to do norm CDF, lower bound, upper bound, mean, standard deviation. So second distribution, lower bound, upper bound, mean standard deviation, 0.05. Okay, so if someone is 1.6 standard deviations, oh my God. Hudson! Because if that's 0.05, then that's 0.95, because it has to add to 1. So a z-score of 1.6 means that person's 1.6 standard deviations above 0. And the area under the curve is 0.5, which means that person is in the top 5% or the 95th percentile. So if I said z is less than, 1.2, it's going to be that. So norm CDF, lower bound, upper bound, 0, 1. .88. Okay, we'll stop there.